Hi everyone, here is our math problem for today. We are given this triangle ABC and the measure of side AB is 18 units, the measure of side BC is 30 units. This angle here, angle A is 2x and angle C is x. We would like to find the area of triangle ABC. You can pause the video and see if you can solve this problem. Now let's solve this problem together. Let's begin by constructing this line segment, and let's call this segment BD in such a way that we form here an isosceles triangle. That means this side has the same length as side AB. This angle here also must be the same as this angle, so this must be 2x also. Then let's look at this green triangle. With respect to the green triangle, this angle BDA with a measure of 2x is the exterior angle of interior angles BCD and angle DBC, which means that the sum of this angle here plus this angle here must be equal to 2x, which implies that the measure of angle DBC must be x. This must be x degrees. This means that the green triangle is an isosceles triangle also, and so if the measure of side BD is 18, then the measure of side DC must also be 18 units. Next, let's construct this altitude that is perpendicular to the opposite side, and let's call this point as point E, and let's call the length of segment BE to be h. Then, let's consider this right triangle. Using the Pythagorean formula, h squared is equal to the difference between the squares of the hypotenuse and leg ED. So we have 18 squared minus the length of segment ED squared. And simplifying, we have h squared equals 324 minus ED squared. Next, let's look at this other right triangle. And let's also form an equation with respect to h squared. So h squared, which is the square of one of the legs, is equal to the difference between the squares of the hypotenuse, that is 30 squared, and the remaining leg, which has a length of 18 units plus whatever is the measure of segment ED, and square that. 30 squared is 900, and this is a square of a binomial that is expanded this way, and further simplifying, we arrive at h squared equals 576 minus 36 times the length of segment ED minus the length of segment ED squared. Now, at this point, we have this equation for h squared, and we also have this other equation for h squared that we derived previously. Therefore, we can now form this equation. This h squared, which is 324 minus ed squared, is the left side of our equation, and this 576 minus 36 ed minus ed squared is the right side of our equation. You have here minus ed squared and minus ed squared. We can eliminate them by adding ed squared to both sides of this equation. Then let's subtract 324 from both sides of the equation to arrive at this. Simplifying, we arrive at ed equals 7. So the length of this segment ed here is 7, and this AE is also 7. So we now know what is the length of the base AC, but we do not know yet what is the length of the altitude h. But by knowing the length of ED to be 7, we can now solve for h this way. H squared equals 324 minus ED, which is 7 squared. So 7 squared is 49. So h squared is equal to 275. Getting the principal square root, we have h equals 5 square root of 11. So, we now know the base of triangle ABC, we know the height of triangle ABC, we are now ready to find its area. Area is equal to 1/2 times the base of 32, 7 plus 7 plus 18 equals 32, and h is 5 square root of 11. 1/2 of 32 is 16 times 5 is 80, so we have 80 square root of 11, which is approximately equal to 265.33 square units. And this is now the area of triangle ABC.